Good morning, my dear students. My name is Sharma. Today we are going to know a very important concept about resistance. So one of the important concept for all board exam. Okay, about resistance. So resistance means one which opposes the flow of electric current. So what is electrical resistance? One which opposes the flow of electrical current, that is direct current. So actually we have two currents, alternating current and direct current. Okay, time being you remember, direct means current which does not changes its direction. Okay, alternating means which periodically changes the direction. So usually all electronic circuits know. So in electronic circuits we send direct current. Okay, so current, this direct current opposed by a conductor called resistor. Okay, so resistor is an electrical device which will try to oppose the flow of direct current. So how we define this electrical resistance? So this can be defined by using Ohm's law. Okay, so you know, according to Ohm's law, potential difference between the ends of a conductor. Now, potential difference between the ends of a conductor is given as, you know, IR. Now, current into electrical resistance. So remember, resistance is defined as ratio of, okay, ratio of potential difference between the ends of a conductor to flow of current. Okay, ratio of potential difference between the ends of a conductor to rate of flow of charge, nothing but you can say current. Okay, so ratio of V to I gives resistance. Okay, so this is the symbol of resistor. Okay, this is the symbol of resistor. So if you put an arrowhead across this, we say it is variable resistor. So if you are just writing resistor, it is called a fixed resistor. Okay, and measurement of resistance. So remember, resistance is measured in ohm. Okay, it is the symbol of ohm. For example, you see there is one conductor, resistance 5 ohm. So the opposition given by the conductor 5 ohm. So in this way you can measure resistance. So now we are going to know the combination of resistors, and based on the combination we can solve some problems also. Usually in the board exam you will be given series combination wise, otherwise parallel combination wise one question will also be given. Okay, so we'll solve that problems also. Please try to watch the video till end. You will definitely get confidence about resistance. Okay, now we are going to know about effective resistance of resistors when they are joined in series combination. Okay, so series means, remember, current through each resistor remains same. So whenever number of resistors are connected in such a way that current through each one remains same, then they are said to be connected in series combination. Okay, suppose there are three different resistors of resistances say R1, R2, R3. Okay, or join in series combination. You see, only one joint is common end to end, so that is called series. Okay, so three different resistors are joined in series combination. Okay, so there current through each one remains same, that is when ends are connected to a battery. So whenever you give power supply to the ends to battery, thereby current flows through these three resistors remains same. Very, very important point. Remember, in series combination, flow of current through each resistor remains same when you have given power supply to them, okay, through a battery of V voltage. Okay, next certain potential difference will develop across first resistor, second resistor, third resistor. Let us assume V1 be the potential difference, okay, across R1 means first resistor, okay, of resistance R1 ohm. Next, V2 be the potential difference, okay, across second resistor of resistance R2 ohm. Okay, next V3 be the potential difference, okay, across third one, say R3 ohm. Okay, so V1 is across first one, V2 across second one, V3 across third one. But total potential difference, the ends is equal to sum of the potential differences. So total voltage is equal to sum of the potential differences, sum of the voltages. According to Ohm's law, V is always equal to IR, current into resistance. So I is the current flow through each resistor, and R is the effective resistance. Okay, so when you join three resistors in series combination, the effective resistance offered by them is RS. Okay, so that is equal to V1. According to Ohm's law, V equal to IR, no? So I R1, because I remains same. Why? They are joined in series combination. So I R1. So here I you are representing with capital I. Okay, plus V2, potential difference across second one, that is you can measure through Ohm's law, V equal to IR, so IR2, plus third one, I R3, because current through first one or second one or third one remains same. Why? They are all joined in series combination. Okay, so if you notice, I is common now. So R1 plus R2 plus R3. Okay, so I you can cancel. Therefore, effective resistance, okay, is equal to sum of the resistances. So what do you notice? Whenever you join resistors, Okay, or series combination, the effective resistance is given as sum of their individual resistances. That means, whenever you join resistors in series combination, they offer maximum resistance. No, because R1 plus R2 plus R3, no. So, remember, whenever you join resistors in series combination, okay, current remains same, okay, and potential difference divided, no, and offers maximum resistance. Okay, so whenever you join resistors in series combination, they offer maximum resistance. Suppose instead of 3, you have given some n number of different resistors. Then you can extend your formula R4 plus, okay, R5 and so on up to Rn. So this formula you can extend for number of resistors. Okay, so now we are going to know when resistors join in parallel combination. So remember, whenever resistors are joined in parallel combination, potential difference across each resistor remains same. Okay, so how you define a parallel combination of resistors? Number of resistors are connected in such a way that potential difference across each one remains same. They are said to be connected in parallel combination. Okay, so in parallel combination, remember, potential difference remains same. But when all the first joints, first resistor first ends are connected to positive terminal of battery, the next end, second end, connected to negative terminal of the battery. So one end of the resistor is connected to positive and all the other ends are connected to negative terminal of the battery. They are said to be connected in parallel combination. So in case of parallel combination, so from here I current started, but it will divide into 3 paths. Say I1 through first one, I2 through second one, I3 through third one. That means total current is equal to sum of the currents. Okay, remember, whenever you join resistors in parallel combination, potential difference, say V, remains same and I divided. Okay, so total current is sum of the currents. So we know, according to Ohm's law, V always equal to I or not? Then I taken as V by R. For our convenience, take RP. Okay, means resistors in parallel combination. Nothing but effective resistance. So resistance offered when they join in parallel combination is RP. Okay, so that is equal to I1. I is V by R now. So V by R1. Why V by R1? Because the resistors are joined in parallel combination. In case of parallel combination, V remains same now. So V by R1 plus I2 V by R2. No? plus I3 V by R3. Okay, so V is common now, you can cancel. So you know 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So resistance offered in this combination is minimum. Okay. So Rp gives minimum resistance. Okay. Series combination gives maximum resistance. So remember, whenever you join the resistors in parallel combination, okay, current divided. Okay, and potential difference remains same. Okay, so in case of parallel combination, V remains same and I divided. In case of series combination, remember I same and potential difference, you know, divided. So if you know these 2 points, no, it's easy to solve any problem. Okay, so resistors in parallel offers minimum resistance, resistors in series offers maximum resistance. Okay, so based upon this we'll solve problems also. Now let us suppose there are two resistors, okay, taken in the form of letter V. Okay, so you want to find the effective resistance between the ends, say A, B. How? So this is your given problem. Two resistors you have taken which are arranged in the form of letter V. So if you notice, only one joint is common. No? For first and second, only one joint is common. So you know, whenever one joint is common, it is said to be connected in series. No? So effective resistance taken as R1 plus R2. Okay. Now instead of letter V, say they are arranged in the form of letter U. So you have taken three different resistors which are joined in the form of letter U. Okay, so you know, in this case also the resistors are having only one end common. See, for first and second, this end is common. Second and third, this end is common. So only when one end is common, it is nothing but, you know, series. No? So what is the effective resistance? You know, R1 plus R2 plus R. Now in this problem, you know, 5 different resistors are arranged in the form of letter H. So you want to find effective resistance between these two ends. So this is your given problem. Five different resistors are arranged in the form of letter H. You want to find effective resistance between these two ends. Okay. So you know, current starts flowing from this end. You know, when it is given, when you are given a power supply, no, through a battery, current starts flowing through this path. But you know, this end is open. No? So current does not flow through this resistor. So it is neglected. Okay. And this is also neglected because this end is open now. So current flows through R1, next R2, next R5. So what is the effective resistance in this case? R1 plus R2 plus R5. Okay. Suppose you want to find resistance between these two ends instead of AB. Okay, so now current flows through this only, the other two are neglected. No, so this is your problem. So you want resistance between C and D instead of AB. Okay, so this is taken. No? Next, this is also taken, this is also taken. These two are neglected. Why? Because open now, current flows across this path. That means what is the effective resistance in this case? R3 plus R2 plus R4. Okay, that is if you want to find resistance between C and D instead of AB. Okay. Now you have given three different circuit type problems. Okay, so now we are going to solve those three circuit type problems. Now look at this problem. With different resistors, it is forming a triangle. Okay. So you want to know the resistance between two endpoints is maximum. That you have to find. Okay. So whether it is maximum between PQ or QR or PR, that we have to find. Now you see, first we'll calculate resistance between P and R. How many resistors are joined? 3 resistors are joined in parallel combination. Whenever resistors are identical, no, we take R by N. Okay, so here resistance of each one is R, no? So it is small r by 3. Why? 3 identical resistors, each of resistance small r joined in parallel combination. So resistance between PR is R by 3. Now you see between Q and R. R by N. So each resistance is smaller and you have given 2 resistors, no? That's why it is R by 2. No? So effective resistance between Q and R is R by 2. Now last one you see resistance between P and Q. Only one resistor now of resistance R. So what do you notice? Resistance between P and R is R by 3. Resistance between Q and R is R by 2. Resistance between P and R, P and Q is R. So what do you notice? Resistance is more in this case. No? So resistance between P and Q is equal to R, no? So that is only maximum. You already know whenever resistors are in parallel combination, no, they offer minimum resistance. If you know that point, straight away you can refer this point P to Q. Okay. Now about this problem. See, in this problem you have given resistors. 4 ohm, 4 ohm, 4 ohm, and this is unknown. Effective you have given as 3 ohm. So resistance between A and B is known to you. You want to find this unknown resistor. How? Very simple. See, in between these, there is no resistance, no? So whether you join this 4 ohm to this point or this 4 to here makes no difference. So if you join this 4 ohm to here, you know, it will be in parallel combination now. So two resistors which are in parallel combination, each of resistance 4, no? So 2 ohm, 4 parallel, no? So the effective resistance is 2 ohm. And you know this 2 ohm, this combination is in series to 4 now. Nothing but 6 ohm. That means this complete resistance is 6 ohm. Now this is parallel to this. So you know, whenever you join two resistors in parallel combination, you know, it is R1 R2 by R1 plus R2. So one is 6 and another one is unknown now, R by 6 plus R. But according to this problem, the effective resistance is given as 3 ohm. That means you can equate this to 3 now. So you know this 3 divides 6 2 times, right? So you get 2R, no, is equal to 6 plus R, or you take this R to left side, R equal to 6 ohm. So what is the unknown resistance value? 6 ohm. So the value of this unknown resistor is 6 ohm. So here you know in between them no resistor is given. So I will join this end to here. So that you know they are treated in parallel combination. Next to it is only one end now. That's why series. So next to it parallel. According to problem, the resistance between A and B you have given 3 ohm. So that is why it is taken 3. So when you further simplify it, you got unknown value as 6. Okay, so remember whenever two resistors are in parallel, R1 R2 by R1 plus R2, that is when they are different. So in case of identical, it is R by L. Okay, so now about next problem. Now you see, you have given certain resistors in this combination. You want to find resistance between A and B. So 2 ohm, 2 ohm, 2 ohm. Next 2, 3, 2. 2, 3, 2. You want to find resistance between A and B. How? Remember, whenever you want to find resistance between two endpoints, no? If you elevate and observe the circuit, no? It's very easy to solve. So if I elevate in this way, you know, first I get on the top 2, 2, 2. Series combination, no? So series combination of these three resistors, you know, 2 plus 2 plus 2, 6 ohm, right? Next to it parallel now. So you know, Rp is equal to R1 R2 by R1 plus R2, no? So it is total 6 treated as one resistor. This is another resistor. So what is their effective resistance? Two joints same, no? This 3 and this 2 joints same. So whenever 2 joints same, parallel combination R1 R2 by R1 plus R2. So one is 6, another one is 3 now. So 18 by 9, nothing but you know 2 ohm. means you should cut this 3 ohm resistor and you should treat now 2 ohm. Okay, this 3 is now taken out, only you have to treat 2 ohm. Between the ends point effective resistance is now only 2. Okay, now again you see 2, 2, 2. 6 ohm. So this total is again 6. Next to it parallel, no? Like previous one. You know, 6 into 3 by 6 plus 3. So again you get 2 ohm. No? So in this case 3 again taken and taking 2 ohm. No? So 2, 2, 2. So final resistance is 6 ohm. Very simple. So what is the effective resistance between A and B? 6 ohm. How we solve this problem? So if you want to find between A and B, elevate and observe. First loop, 3 series, next to it parallel. Again 3 series, next to it parallel. Okay. So 2, 2, 2, 6 na, 3, parallel, you get 2. So 2, no, 2, 2, 2, 6, next to it parallel, another 2. So 2, 2, 2. Effective resistance is 6 ohm between A and B. Okay. Now let us suppose you have given a cuboid and you want to find the effective resistance between the square ends like this, or they may ask you to find between the rectangular ends. Okay, now suppose this cuboid length is L, okay, breadth B. You want to find first resistance between the square ends. Okay, so you know resistance of a conductor, you know, rho L by A. Remember, where L, you know, length of the conductor, A, you know, area of cross section. No? So here resistance you are finding between square ends. Okay, so rho as it is, you know, length of the conductor, in this case it is L only, no? So L by area. So you know it is in the square form, no? Cross sectional one is in the square form. So you know area of square, side into side, no? So that is, you know, B into B. So it is rho L by B square. Okay, so that is the resistance between the square ends. Now instead of square ends, say you want to find the rectangular ends. Say this is one end, the other end down. Okay, in this way. So if you want to find the resistance between the rectangular ends, resistance between rectangular ends. Okay, so you know length in this case is breadth, no? So B is the length of the conductor by area. You know area of this cross section is, you know, length into breadth now, because you know cross section is in the rectangular form, you see. No? So it is rho B by L into B. So that is about resistance between the rectangular ends. And you know, if you are considering in this way, you know, this is the length and area is square form. Suppose you are finding resistance between the rectangular ends, you know, this is length and cross section is rectangle. Cross sectional area is rectangle. Okay. If you like this video, please like, share and forward to your friends. I am going to give you more and more updates related to this 10th standard based upon ray optics, okay, electricity, all important concepts will be given.